Hi, everyone. Before we start, a little bit about me. My name is Jatin Katyal. I'm a customer success specialist with CX, and I'm based out of Dallas, Texas. So today we will talk about Rapid Threat Containment with Cisco ISE and FMC. With that said, let's talk about our today's agenda. So we will have a couple of poll questions, couple of demos, and we'll also discuss about why we need integrations with other security controls with zero trust, and how can we build context and share that context with FMC. So why are we talking about integrating security controls? For years we have developed different products, firewalls, IPS, IDS, and those are managed by different teams. We have been sending our logs to SIEM and syslog. We do a lot of automation analysis on SIEM and take action on those devices. The reason why we are talking about integration of security controls now is because of the complexity and because the networks are no longer what they were used to. If you go back a few years, you start seeing so many micro applications in cloud networks. During and after the pandemic, users are being more remote. Your network application access and users are no longer predictable. The devices and network they connect from, none of them are obvious anymore. And to provide security with these changing networks, what we have done, we have deployed more and more security products. Since your network are no longer predictable, we must react to changing environments by evolving, by integrating other security products, making them work smarter and even better. But most importantly, we have to have them to react to incidents and events before any human can look into it. If you look at some of the past well-known publicized attack or hacked events, you would realize the companies are being compromised. When you look at the investigation and diagnosis of those events, you would notice that all the logs showed that the attack was in progress, but nobody saw them and could not take any action. So let's try to understand this with zero trust and how ISE can help. So ISE provides zero trust in the workplace with established trust, enforced trust-based access, continuously verified trust, and response to change in trust. And we also call it containment. To achieve resilience, we believe an organization must perform these four functions to implement zero trust. Let's try to discuss some of them in detail. Establish trust. So unless you know what devices, users, applications are on your network, you cannot really define risk. You cannot define how to mitigate them. And you cannot put control in place. So visibility is where it all starts. Here, ISE authenticates all the users and endpoints and can profile and posture them to provide visibility into who and what they are. The next one is enforced trust-based access. We also call it segmentation. Now that can be used to authorize them, the endpoints, and provide segmentation to enforce the principle of least privilege. We started doing this by pushing ACLs, VLANs, and now we do it with STGs. Continuously verified trust. We all know that change is inevitable, especially when it comes to risk. So continuously verify trust by reassessing the trust level and adjust access accordingly after the initial access was granted. And we will notice, in today's demos that how we are using these, different categories of zero trust using ISE. The last one is respond to change in trust. ISE always, able to leverage the security products and service integrations. It can dynamically respond to change in trust by investigating and orchestrating response to potential incidents with increased visibility into any suspicious change in the trust level. We all know that today, even with a lot of security mitigation in place, we can still have an incident. And what important is to understand that the incident does move lateral. In such situations where one infected device can infect the whole network, and suddenly you are now at the mercy of the attack, it's important to definitely think about automating the containment. So yeah, when we automate containment of those infected endpoints and revoke network access of those users, we stop them to move lateral. Now the challenge here is that do we really have a security product that can do all of these together at one point? Just one product. If you're thinking about ISE, you're partially correct, because ISE can do all of this. It can definitely give you a lot of authentication methods and authorizations. It can definitely push VLAN, SGT, ACL down to the network device, and it can also contain devices like, it can say something like, something bad happened in the network, and now we have to take some action. It could be quarantine VLAN or quarantine SGT. Yes, ISE can do all of that, but ISE can only suggest segmentation, and it relies on the network access devices to enforce segmentation. It can say that this user belongs to this particular group or VLAN. It is a firewall or switch at the edge which enforces the segmentation. ISE can contain a device, but ISE doesn't know when to contain. Something else is needed to tell ISE that something happened in the network, and ISE need to contain the user or the device. It could be firewall with a malware module on it. So ISE can do the visibility, ISE can do the classification, but it has to rely on the network access devices to enforce segmentation. Moving on to the next slide. Here we will talk about context build. So on the other hand, if you look at enforcement devices, that is firewall, switches, what they all care about is traffic. It could be a source traffic, it could be destination traffic, ports, protocols, and they do it based on the IP address. Like all the network access devices perform the section based on the IP address, but they do not know who is behind that IP address. It could be company CFO or HR who has downloaded the malware. What if they knew it, that it's the company CFO? And then we can decide what needs to be done. So let's quarantine the CFO and allow web access only, and ensure nothing else go out to the network. This is called reaction based on the user role. What if your firewall could do that? It will make the life of the incident responder much easier. Many attributes that you see on the slide can affect an endpoint authorization to the network. Who the user is, what type of device it is, how it is connecting, from where it is connecting, when it's connecting, whether it's compliant or not. Did we detect any threats? We collectively refer to these policy inputs as context, which ISE uses to make an authorization decision, which can be classified with a security group tag. Now, ISE shares this whole context with other security services. It can use syslog, it can use REST API, or it can use pxGrid. And today's session will be focused on the pxGrid. So all the context I gave you so far is to understand why we need to have security integrations. Now we will discuss how can we do it. On this slide, we have different categories of pxGrid, like how we can share the information with other security products, and how ISE can also fetch that information. Let's discuss in details. So pxGrid is a subscription-based communication framework that first Cisco came up with, but now it's a RFC, and it's used by non-Cisco products. In this whole demo, we can use pxGrid to integrate ISE with FMC. ISE is the only known controller of pxGrid ecosystem. There could be other participants who can join the platform, but once pxGrid platform is started, the ISE can share the user context with the ecosystem partners. On this slide, we have 4 scenarios for using pxGrid. The first and most common is for ISE to notify all subscribed applications about a new endpoint and its associated context. The second is when another security service shares information with ISE to improve its context and update policy authorization based on the new information. And the third is threat mitigation. That's possible when ISE receives an explicit quarantine action from a trusted application or pxGrid client that is often the result of a malware detection or a behavioral trigger on an otherwise trusted endpoint or user. We will try to understand all this, with our first demo of this session. But before that, we will have one of your poll question, and that is which Cisco or non-Cisco product have you integrated using pxGrid with Cisco ISE? All right. I started to see some responses from you guys. And I can definitely see one of the responses definitely taking a lead. Cool. Keep them coming. I read the question one more time. Which Cisco or non-Cisco product have you integrated using pxGrid with Cisco ISE? StealthWatch, FMC, DNAC, other. Cool. So the first winner over here is DNAC, and the second one is FMC. Oh, I was expecting the same results. All right. There are a few people who are planning to do with, Cisco DNA and StealthWatch. Thanks for your response. But definitely we have the StealthWatch, FMC, and DNA, the top 3 winners. All right. Thank you so much again. And then this is our first demo of our today's session, that is integrating ISE and FMC using pxGrid. In this demo, we will talk about how you can integrate ISE with FMC using pxGrid, and then we will also show you how to create the identity policy and access policy. And then once we have the context on the ISE side, how that context can be shared with FMC. In this demo, I'm using FMC 7.2.5 and ISE version 3.2. So it's a pre-recorded demo. You will notice me pausing this video a few times to explain you some of the topics. There you go. So the first thing that we will do here is to enable pxGrid on ISE. That should be under administration deployment. And at the bottom of node, you would notice that there is a slide that you need to move and then save the settings. The next thing we will go and check the pxGrid certificates. Here I'm pausing the video to explain a few things. So this section is a lifesaver in Cisco ISE. The certificate chain that ISE uses to authenticate pxGrid client versus authenticate pxGrid clients versus authenticate the admin and guest portal can all be very different. So it's not unusual for ISE to use different certificates issued by different CAs for different use cases or purposes. The good part is that ISE can act as a certificate authority and can generate the pxGrid client certificate from its own UI that you can move later or import to another product that is going to be act as a pxGrid client. In this case, we have FMC. Now we are going to generate the FMC pxGrid client certificate from ISE GUI and import it on FMC so that it can use that certificate to communicate with pxGrid server and gets all the context. Here we will generate a single certificate without signing request. So let me resume. In the common name, we usually use the host FQDN. And then you can put the description that makes sense to you. Now, if you are using something else in the CN, then you definitely have to use SAN with the correct FQDN. After that, you will use the certificate in privacy enhanced file because FMC likes all the PEM files to be separated. And then you type the certificate password to encrypt the private key file. And then you save the changes. Once you do that, you create a zip file, and we'll talk about the ingredients of that zip file later. Now, I'm going to FMC, and let me pause the video here. If you notice here, in the FMC system integration identity sources, we are going to put the IP address of your primary pxGrid controller. Okay. I'm explaining a few fields ahead of time, but then you can see in the demo as well. In the pxGrid client certificate, we will use the certificate that we have just generated, and I'm about to show you in the zip file. And then I'll explain you the MNT server and MNT Server CA. So I'm going to open the zip file to show you what we have inside that. Okay. Here, if you notice, we have the first one that is FMC pxGrid32.cer. That's the identity certificate for FMC, where we used the CN as the FQDN. And down below, you can see the private key file. The rest all, is the certificate chain. Now, this FMC certificate is signed by ISE Endpoint Sub CA. Okay. So here, if you look at the plus sign of FMC server certificate, when you click on it, you can put the file, the certificate file in the private key file. And then here you have the MNT Server CA and pxGrid Server CA. Let's talk about that as well. So in the pxGrid Server CA, you will use the root CA certificate of primary pxGrid node that has the pxGrid service running. Right? And in the MNT Server CA, you will use the root CA certificate of your primary MNT node for admin role. Right? Now, sometimes you might be thinking like, why we have a separate field for the MNT Server CA? That's because if a customer is using a different certificate authority for their MNT certificates, then yes, we definitely need to import that as well. After that, you will select, the subscriptions, like what topics you would like to move on to the FMC, that is session directory topic and SXP topics. Let me resume the video. Okay. Just a second. I think my mouse is not really helping me to run this demo smoothly. We were somewhere. Let me turn on it again. Yeah. So if you notice, we clicked on the test button and we got the success as a result. 95 to 99%, your first test most likely going to be fail if there is a setting on ISE that is not enabled. Okay, we'll talk about that. Secondly, if you are still failing this test option, then most likely you are running into some certificate issues, right? Now, after a minute, when you click on test and go back to ISE, you would notice the new FMC client that has been added. So we'll go to clients and then we go to the client management and you can see two entries, one for the test that we just ran and the other for the FMC client. Both are enabled in the status. And then in the diagnostic, you can see all the ISE nodes that authorized and subscribed without the approval. But at the bottom, you can see the FMC slide that shows connected. And now I'm going to talk about the setting that you should enable or you should manually enable after the client has requested access. So here, if you notice that we have two options. One is automatically approve new certificate-based accounts and allow password-based account creation. In the production setup, I do not encourage you to keep this option enabled, even though it's certificate-based authentication. But in the lab, if you want to keep it enabled, that's fine. The second option that we have is allow password-based account creation. I have not seen this being used by any commercial product. As far as I know, this is being used by the developers when writing a custom codes. So once you click on test, if it's failing very first time, come back here, allow the client, and then go back and run the test again. So once that is done, you also need to configure a role. I have pre-configured it here. The reason why we need it is because pxGrid node is tied to the realm of FMC. When pxGrid does send information down to FMC, FMC does take the IP address to AD and tries to resolve it to user and group information. Once the realm is configured and working with AD, you can create the identity policy. The way you can test whether the realm is working on FMC or not, you can click on the load groups and it can fetch all the groups from the Active Directory. You can include the groups that you would like to restrict to, and that helps with the performance. Resuming the video again. So now we are going to identity. Now you can create your identity policy or edit since it's pre-created, and you just need to make sure that you have ISE pxGrid realm linked to it. So when you click here and click on the drop-down menu, you can see ISE pxGrid AD. The next part that we have to discuss here, we have to go to the access control policy, where you push down to FTD for actual filtering. So let's go there and edit the access control policy. You assign your identity policy here, that is pxGrid ID, and then you check the rules that we have created. In this rule, basically I'm emphasizing on action that I have used block with reset and the network from where the traffic is coming, and then dynamic attributes. And that you can see how you can fetch the security group tags from ISE after establishing the pxGrid connection. So once that is done, you can save. And finally, you will deploy it to the FTD. Here, we will try to authenticate from the client. And then we are coming back to ISE to check. So this is my client from where I'm trying to access the FTP site. And it's working, right? So the reason why we have done that, because we would like to create some traffic, okay? And now let's go back to ISE and see how the context is being built. So first we are checking on FMC to see in the connection events, what is the source IP, what is the destination IP, who accessed this site. So the user that we are using for this testing is employee 1, that is authenticating through .1x from the switch. When we authenticated through that user, we got the IP 10.1.10.10, and the username is employee 1. The IP that we are trying to access is 10.100.226, that is the FTP server IP. So that's the IP of the destination. And you can see the source STG that we have got as employees. That means we have full access to the network. Now, what will happen if the user is going to download the malware, right? That I'm going to show in demo 2. You cannot just see the IP address of the user, but you can also see the username attached with it. We will experience that in our second demo, and I will show you from ISE and FMC side. All right. So in the second demo, we are going to talk about how to configure the RTC on FMC. But before that, I wanted to give you a quick, example, like how it feels like in a real network environment. So if you see here, we have all the users, Jim, Harry, and Abyss, and all of the users have security endpoint in. When a trusted employee, Jim, connects to the network, he is given full access, right? At some point, when doing his work, Jim clicks on a bad link or downloaded a suspicious file, causing an infection on his computer. Secure Endpoint reports this infection to the cloud. Because of ISE pxGrid integration, it is notified of Jim's high threat, which shows up in the ISE dashboard previous line logs. Armed with this new information, the admin will have the option to quarantine this user device, right? As we have understood that a firewall or a malware module has detected an event that shouldn't have existed is there. So in short, when malware was detected, we have blocked the user. But now, how are you going to trust that user any longer? At the least, you can say that this user is now at a very high risk. And for next few days, we are going to assign the user to a different group or going to have a deeper look at its traffic. Assign a stronger IPS policy maybe, or change the malware lookup. Earlier, we only wanted to have the executable to be sandbox, but now we would like to have PDF, the Word docs to be sandbox as well. So you can apply different strategies on the user for this drill to be executed. But you can block the user as well to certain portion of the data center. This is what we call rapid threat containment. In short, if we try to understand from FMC perspective, FMC is there to react to an event and send message to ISE to quarantine this user. And then you define on ISE what quarantine means to your organization. Does it mean to change of a VLAN or change of SGT, or does it mean deny access entirely? So it is something that every company decide based on their requirements. Now I would like to talk about a few facts about RTC. You cannot do RTC on FMC without the integration of pxGrid. And we have already shown you in the demo number 1. You have to create the identity policy, access control policy, realm, and also integrate the pxGrid at the same time. And based on that information, we can create, or based on the information that firewall collects, we can create your correlation policies. Always remember that RTC is a feature of FMC and not the FTD, because all the correlations and reactions are to be done by your FMC. All right, so we are moving on to the demo number 2, and that's the last demo of our session. So here we will talk about the configure ANC policy on ISE, configure remediation and correlation on FMC, and events analysis on FMC. Before we jump to the demo, I would like to give you a little bit information about ANC. So ANC is an adaptive network control. It is a service that runs on the admin node of ISE. The service monitors and controls the network access of the endpoint. And it can be invoked by ISE UI admin, or you can also invoke it through pxGrid from a Cisco or non-Cisco device. ANC only supported with wired and wireless networks. It needs the Advantage license, and by default, it's disabled. So it will be enabled as soon as the pxGrid will be enabled on your ISE node. Okay. Let's move on. So this is our second demo, and before we talk about correlation, what exactly the correlation is. So whatever firewall is doing to detect a malware or any unusual behavior, we use that data or that information, and we use that data to invoke the correlation policies on FMC. The correlation policy is a construct that is made up of correlation rules and remediation. And what are correlation rules? It is a rule that is housed inside the correlation policy that is configured to look for one or more security events. There can be more than one correlation rules inside a single correlation policy. Okay, so this is like quick information about ANC and correlation policy. We'll move forward with our demo, and then I'll also explain you a couple of other components of correlation policy, that is remediation module and remediation instance. So in order to configure RTC, first we have to create the ANC policy on ISE. So here I have created an ANC policy with name AMP quarantine, and the action I have created is quarantine. Right now, I don't have any endpoint assigned to this policy. That means no one has downloaded the malware. And now we are going to FMC inside the correlation policy. And I'm going to click on remediation, because the first thing we would like to configure is the module and instance. So there is already a module configured. If you see pxGrid adaptive network control, we'll edit that. And inside that, we have to configure the instance. So instance is ANC quarantine. So ANC's instance, ANC policy assignment 1.0 is your module. At the bottom, you can see remediation configuration. And the remediation action is ANC policy for source because we are detecting this whole thing based on the source SGT. And the ANC policy, that means the action we are taking, is AMP quarantine. So FMC is going to use pxGrid to send this quarantine message back to ISE. So inside the correlation policy, first we will go ahead and create the rule that defines the trigger event when the remediation is found. So if you see here, my condition is if a malware event occurs, right, by network-based malware detection, that is FMC and FTD, and the file type is zip, this rule should fire off. That's all we are correlating here. You can make it as complex as you want, but for the sake of this demo, I just created a simple one. Now we are creating a policy, and inside that policy, we have a policy rule. And now we are assigning the action to that particular rule, that is ANC remediation, from unassigned to assigned. On the ISE, if you notice, after the COA, the change of authorization, if we found that user or device has now a different SGT, that is quarantine system, then we should get a different authorization. In the beginning, it was full access, that is SGT employees. So here we are going to radius live logs to check, do we have user employee still access to the network? It looks like we still have the same IP address and the STT shows employees. Let's verify from the switch side. In a couple of seconds, we'll go there and run the show auth command to check if we still have the same SGT assigned. Great, so we still have SGT4, that is employees, as a SGT for user employee 1. Now we are going to our client and try to download the malware. As soon as we do it, we hit the block with the reset action that we have created on FMC. Now we'll run the same command again to see, did we get a different SGT? And yes, we got 255, that is quarantine system. Let's go and check the ISE logs first. Do we have a different SGT? That should be quarantine system. For the same user employee 1, yes, it's there. So we'll go back to FMC and ensure by running all the analysis to see if the correlation rule was configured and triggered fine. So first we'll go to malware events. It takes a couple of seconds to have those entries here. Yeah, so we have malware block for sending IP, that is 226 my FTP server, and the receiving IP is the client IP for employee 1. Threat detected in the file transfer, and you can also see the file name and the threat score, and the file type is zip that we have configured in the correlation rule, and that's my file policy. So everything looks good from the malware events. Based on the information firewall has gathered and based on the correlation rules we have configured, it should definitely trigger the correlation rule. Let's check from the logs. So yeah, same IP, source and destination IP, same username. And if you check here, the rule that we hit was detect malware to quarantine, and policy is AMP RTC policy. Now we'll go to correlation status to see if the correlation was triggered fine. And yes, we can see for the remediation name that we configured and the action and the policy and the rule, the result message shows successful completion of remediation. That means the FMC was able to inform ISE using pxGrid that you quarantine this end user. Now we are going to ISE Adaptive Network Control Endpoint Assignment. And here we can see the MAC address of that endpoint has been assigned to this policy. There are two options to to release access back to this client. One is from ANC and the other one is like context visibility. So you can go to context visibility endpoint and select the MAC address, and then you can revoke a policy. That means you are unquarantining this endpoint, and this endpoint should have access to network once again. So if I run the same command here, I should get back my employee STT, that is 4, because we have manually revoked the policy from ISE. And if I try to access my FTP server, again, it should work. Okay. So that's the end of our second demo. Now, if you notice that what we have done is a simple concept of cause and effect. So on FMC, we have created a policy that shows says, if the rule fires off, then take some action and send the response remediation to ISE. Okay. One quick thing I wanted to tell you that in the correlation policy, when we create it, after that, we should enable it, because by default, when you create the correlation policy rule, by default, it's disabled, so you have to enable it. And then I wanted to give you a quick, summary of what we have done so far in the second demo. So when a malware is detected by the FMC, right, based on that information, a correlation rule was triggered. The pxGrid mitigation module that we have built in on FMC sent a ANC quarantine message to ISE, and based on that message, an endpoint was classified or assigned to an ANC policy. When that classification occurred, right, a change of authorization was triggered from ISE, and it was sent to the network access device. That is your switch. And a change of authorization will definitely be occurring on ISE as well if we have a new policy configured based on the information we are receiving now. That will be your quarantine system. So again, the quarantine does not mean anything in itself. It is up to you what you want to define for your organization, whether you want to limiting the access of that endpoint, or you're denying the access, or you apply a specific trusted tag. In our recreate or in our lab demo, we have actually assigned the STT so that we can do some more drill analysis on that particular endpoint. So that's the end of our session. Again, thanks for joining today.